All right, hey everybody, Mr. Fortin here. Sort of said I'd send another video along, I guess, to maybe help you finish this one out. But I think you're probably doing okay on these earlier slides here. Definitely message me if you could use some help, and I'm willing to answer questions. And maybe some of this was a bit harder than maybe I'm anticipating, and I might need some help here. Anyways, Vertex here, you definitely need a negative a, 0, negative 13 is this guess and check. I don't know, one specific parabola, so that point, and you have a y-intercept and a vertex, yeah, we might have to figure out what a is, I guess. We might have to solve for it, I guess, here. So anyways, you might be using this in the problem that I'm going to show you, which is going to be involving solving for a. So on slide 13 and 14, looks like they're kind of previewing this for you here, is that if you know you have a vertex, right? If you have a vertex at 3, 5, you know, this is where the 3 is going to appear in the vertex form. And this is where the 5 is going to appear in the vertex form. And then the only parameter that you wouldn't know is the a. Remember, what are the 3 parameters in vertex form? A, h, and k. Okay, h and k. So if you know what h and k are, and you know what one point on the graph is, you have the vertex, you have a y-intercept, you can figure out what the equation is because you'd have everything you need to know about the vertex form. You know h, you know k, and you know what 1x is and what 1y is. You just don't know what a is yet. So anyways, they're kind of previewing this for you here, but the idea is similar to how we solved for b earlier this year. Like, remember when we didn't know what a y-intercept was of our lines, right, our linear equations? So our linear equations are written in the form y equals mx plus b. If we knew the slope and we knew a point on the line, slope and a point on the line was enough to get the line. Enough to get the freaking line because we know what x was, what y was, and what m was that would work in our equation. We just didn't know what b was. There was one unknown. Very similar here. If we're given a vertex and one point on the parabola, we should be able to figure out the equation of that parabola, shouldn't we? Because here, if we know one point, we have an x value of 0 here, and we have a y value of negative 13. And remember, you're a point on the graph because you satisfy whatever equation you're trying to write right here. So we know that ultimately negative 13 is going to be equal to whatever our stretch factor is, times by 0 minus 3 squared plus 5, because it goes through these 2 points. It goes through 3, 5, and it goes, and that's where our vertex is, and it goes through this other point here. So they're sort of showing this for us here. What we're going to do is something similar to it, which is going to involve how do we solve for a to figure out what's here. So finish solving for a below, click the square root symbol below to type in math and show all your steps here. So might do this slide 14 to take through this here. Well, if y equals a times by x minus 3 squared plus 5, right? We know what our vertex is. We're plugging in our vertex here to where h and k appear, of course. Remember, the vertex form is just this. Vertex form is, do I have it shown here? Yeah, I do have it shown right here. This is the vertex form. Y equals a times by x plus h squared plus k. So you just got to flip the sign. Then don't flip the sign. Anyways, you input your vertex. Now you can input your coordinate pair of the other point that you have. You have this point up here at 0, negative 13. So now we got to solve, okay? Can you do that for me? Can you do that? Well, let's check it out here. If we have this here, left side's not going to change at all as we're solving for a. So we got to solve for this. Look here, this is the only unknown, only variable left here, and we just got numbers and operations happening. We got to solve for that a here. So negative 13 equals not a times 0, a times 0 minus 3, but we have to square it first. Ooh, so this is a little bit tricky here. So we got to remember our Pemdas rules. Pemdas. Parentheses, exponent, multiplication, division, addition, subtraction. That's the order we simplify. Sounds like a song. The order we simplify is parentheses, exponent, multiplication, division, addition and subtraction. Yeah, that's it. Okay, so first thing I need to do is I need to clean up the parentheses, right? That's first in Pemdas. Parentheses here, so I'm going to do negative 3, right? Because 0, take away 3 from it, move down on the number line 3 lower, we get to negative 3. And then eventually we're going to square it next because we do parentheses first and then we do exponents. So we square it, and then we'll think about what we have to do afterwards here. Okay, so we took care of our parentheses. There's nothing left to simplify in this parentheses. Now we got to look what's next in PEMDAS is we have to do the exponent, right? The exponent next. And here, this squaring thing, as when we studied exponents here, Your exponent here's base is the expression right next to it. And we have parentheses here, so that 2 just goes to the parentheses that's right next to it, just goes to that -3. And what do we know about -3 squared? Well, -3 times -3, any number squared is going to be a positive number. Any real number squared is going to be a positive number, that is. But anyways, -3 times -3 equals +9. So if I'm going to simplify this further, right, I'm going to collect that -3 squared and make it a +9. And there we have it, +5, okay? So now we've got this good to go. So we have PE, Pemdas, right? We did the parentheses, we did the exponent. M is next, that's multiplication. So I will do that next. I will multiply the a times by 9, and I get 9a. Okay, -13 equals 9a plus 5. Right, plus 5 there, okay? So there we go. We have this so far. And now, right, we can't really add this. These are unlike terms. And they have 9 a's, and then we have just 5 1's. Those don't go together, right? We can't add a number to a variable, right? We got 9 of those variables, and then we got 5 something different, right? Just 5 1's here. So anyways, or this constant here is 5. So anyways, now we need to solve this here, okay? So remember, when I say solve things, right, this is our variable a right here. You don't want to bother yourself with you want to isolate a. You want to get a by yourself, but you want to look to directly what's next to the a right now. That's not the first thing you want to get rid of. You want to start away from the a. Okay, what's the last thing happening to a in the right side here? Well, first a would get multiplied by 9, and then we'd add 5 to it. So start by simplifying away from the a. Right? That's what we do here. Look away from the a. Look away, and get rid of that thing that's away. Okay, so now I have subtract 5 from this side. I'd have to subtract 5 from this side. So maybe I'll just show the simplification that I'm doing right now. Okay, and now, right, -13 minus 5 is -18, and that would equal 9a. Okay, 9a there we go. Okay, so now I got 9 a's. Those are equal to -18. Is your head spinning? You've been in school all day. Oh, God, there's so much to think about. Okay, yeah, I mean, you just need to isolate a. What do you do to both sides? You divide both sides by 9, okay? -18 divided by 9. Well, 18 divided by 9 would be 2, right? So if it's -18, we just got to make it negative. Yeah, -2. And there you have it, okay? -2 is going to be your stretch factor. -2 equals our a parameter, okay? And that kind of makes sense, I'd say. Does it say sketch it? Do I sketch on this one? Yeah, I mean, we'd have a negative facing parabola. It'd be pretty thin, and it would look something like this. Ugly parabola. But we would know it would go through the point 0, -13, and the vertex, okay? Because 0, -13 would make this equation true, which would be this. This is ask for, we solve for a. This would be, eventually, it doesn't actually do this here, but this would be the equation, right? This would be the equation of it in vertex form. Y equals -2, because that's our a parameter we just found, times by x minus 3, right? Because 3 was the x coordinate of the vertex. Square it up, because it's in vertex form, plus 5. Okay, and there you have it, right? If you don't know what the stretch factor is, you can figure it out as long as you know what the vertex is and a point that the graph goes through, okay? All right, so let's maybe check it out here. Do we have more stuff here? Solving for a, number 2a. We want one specific parabola with a vertex of -2, 1 and the point 2, 9. And it says write an equation in vertex form with the information you know. Anything you do not know, leave in the variable or the parameter. And here we go, okay? So this is how we're going to do this here. So I'm just making up your Thursday assignment right now because we're just going to do one thing kind of quickly. Thursday assignment. I told you this was the main thing here today. We want one specific parabola with the vertex of this and the point 2, 9. So maybe I'll do this on a separate sheet of paper, or I can actually write it in here maybe. This is going to be ugly. It's hard to write in on the Desmos slides here. So what I need to do to get this is I need to solve for a, write an equation in vertex form, which the information you know, and anything you don't know, leave in the variable and the parameter. Okay, so maybe this is actually getting us queued up for the next slide. Yeah, I want to solve for a in the next thing, okay? So in this slide, what you're supposed to do is just, well, I know my equation is this. I don't know what the a parameter is, but I know that my h parameter, the vertex here is at -2, 1. So h here would be +2, okay? Because remember, your h parameter is, will be plus or -2. Wait, this is negative h. So anyway, so it would be +2. You got to change the signs. That's the whole point here. You got to change the signs when you're putting in your h parameter here. You change the signs here. Okay, and then we're going to square it. And then our constant, our vertical shift would be 1 because our vertex is 1 above the x-axis here, right? Negative 2, 1 is our coordinate pair of the vertex. Okay, so we got that. I'll submit that because then we're going to go to the next slide. Oop, I just flickered there. And we need to complete, this is what our starting equation is here too. Hopefully this is what you got so far here, okay? Solve for a by substituting in the second equation for x and y. And let's do this, okay? So I'll type it here so we all kind of see it similarly to what we had on slide 14. Let's check it out here. So I'm going to do this, and my starting equation is this. So let's do this. Let's do it together. Okay, this is my starting equation. And we'll solve for a together because we have another point on the graph, right? We have another point on the graph. X plus 2 squared plus k, and then that'll be 1. Okay, so now we have that other point. So what's the first step? We got to substitute what we know about x and y from that point, because ultimately, if you have a point on the graph, that's a coordinate pair that works in the equation that we need to solve for and get, okay? So it's kind of, it's working backwards. We got the point, we need to get the equation here. So when y is 9 and x were 2, it's going to satisfy, right? Satisfy whatever our equation is once we figure out what the a is here. That would deliver us the 2, 9 as a solution. Anyways, let's check this one out here, okay? Let's go ahead and solve. We need our Pemdas rules here, guys. It's good to practice Pemdas with you guys this late in the year, right? It's important. It's important to practice this solving stuff. Don't get a ton of it this year here in Algebra 1 and this distance learning stuff here. 2 plus 2 equals 4. Square it up. Add 1 to it. Okay, so that was my parentheses cleanup. Remember, Pemdas. Next up, exponent here, okay? So I'm going to do 9 equaling a exponent. Well, what's the base of my exponent? The base is 4. 4 squared is 16. Add 1 to it. Okay, next up, what am I doing? I'm doing 9 equals a times 16 is 16a, right? Because Pemdas, parentheses, exponent. So I did both of those so far. Next is multiplication. A times 16 is 16a plus 1, and there we go. Now we can solve for it. Oof, my equation is looking a lot less scary now, isn't it? 16a plus 1 equals 9. I think everybody in this class can solve this for sure. Okay, subtract 1 from both sides because we want to start simplifying away from the a. We don't want to deal with the 16 yet. That's right next to the a. This is away from the a. This is just noise. This is a distraction. Let's get rid of that plus 1. So I'll do minus 1 over here from that side, and I'll do minus 1 over here from that side here, okay? And I'm going to get 8 equals 16a. And now I need to isolate a. I got to figure out what my stretch factor is. What am I going to do to both sides? I'm going to divide both sides by 16. And so 8 divided by 16, well, 8 times 2 is 16, right? So 8 divided by 16, we're dividing by number that's twice as large as our numerator, so we get 1/2, right? We get 0.5 here, okay? So my answer for a is going to be 0.5. There's my stretch factor. So this is definitely a wider parabola. Okay, my vertex is below a point on the graph. That means the vertex is a low point on the graph here. I'm going to do this, right? It's going to look a little bit wider than what it did before because it's widened out, right? That a is between -1 and 1, right? So it's definitely a wider graph. Write the full equation here, and let's check out. Fingers crossed. Fingers crossed. I'm going to change the pen to, let's go back here. I'm going to change the pen to something fun. Let's find something fun. Why can't I find something fun? I want to do something fun. It's not letting me do something fun. Mouse? Oh, the mouse here. Yes, I'm going to change to something fun. We're going to get there. Ah, I did it already. It spoiled it for you. Okay? We're going to get y equals 0.5 times by, well, instead of putting, well, we put a in already, right? It's our stretch factor. And then we got x plus 2 squared. Can you get the equation? Did you do it? Did you do it just like I did? Did you get the equation like I did? Yes! Look at that. Got my vertex. Perfect. There we go. It goes to the 0.29. Hooray. Hooray. This was freaking great. I love this. This was good. This was good. This was good. We're keeping it 100. We are loving it. We are thinking this is super cool. And of course, hooray. Hooray. We solved for A. We saved the day. We wrote the equation. That was me. I should become a poet, shouldn't I? Right? Should teach those poetry classes. You have to go to an English class. Yeah, you sit through those poetry lessons in English class. Oh man. Anyways, that one is that one here. So, ooh, okay. Here's another one. Ooh, you get another one. You can get more of these tomorrow. I'll need like maybe 3 more That's it. Just 3 more problems. That's it. That's all I'm asking for. So another one solving for A. So might as well do it. I'm just going to get you another example before you got to do more of these tomorrow. So we want one specific parabola with the x-intercepts. Ooh, interesting. Of -5, 0, and 6, 0, and a point on the graph of this. Here are both the equations we know. Let's get rid of these stupid. Oh, it's so dumb. The fireworks here. And anyways, let's do this together. Here are both the equations we know. Okay, we know the vertex form, we know the factor form. Okay, which one of these are we going to use? Well, they're giving us the zeros. They're giving us the x-intercepts. Which ones do those come into play with? They come into play with the factored form, right? The factored form. We're going to use this, right? This is -p. This is -q, for instance, here. So show your work in thinking the text about your goal is write the equation. So we're going to do vertex. We're going to do factored form. Okay. We're going to do factored form because we know the x-intercepts. Okay, so let's just do all the work together, I guess, here. And we know a point on the graph here. So to start it up, right, factored form is what we're going to commit to. We're going to use that to solve for A. Y equals A times by x plus P times by x plus Q, okay? And then we will go ahead and enter in what our knowns are, okay? So we can do Y equals, well, I don't need to do Y, right? We know what Y is here. We're gonna use that other point here. Look, there's a point right here. X is -6, Y is 12. That's gonna satisfy ultimately our equation here. So what we can use is solve for A. So we can sort of work backwards to get what our A is and what our equation is. That would make -6, 12 be a point. That makes that equation true. So what we have here is we got Y is -12. So now we just substitute everything we know. We know one Y value is 12. A coordinate pair is 12, -6. So we'll get to the -6 part later. We don't know what A is, but we know that for this first X here, we can substitute in -6. Okay, now we have P. Remember, got to change the signs. Going to inside the parentheses here next to the X, it's flip the sign, right? Flip the sign here. So we need to do +5, right? +5, okay? And then, right, because -5 plus +5 gives us that 0 that we have. Ooh, zeros, nice. And then next one here, -6 plus 6 brings us to that 0. So that's going to be what my Q is. So it's -6. Oh, nice, -6. Got 2 -6s in there, right? Yeah, it's +6 here. No, -6 is our Q. And there we go. Let's go ahead. Let's solve for A. Let's do it again. I'm excited. Solving for A is a good time. Solving for B is good as well, too. When you're doing Y equals MX plus B. Anyways, oh, man, days are long at school. Oh, you got to think about so much. Okay, we got A. Now we got to do -6 plus 5. That's -1. So, again, PEMDAS, right? What you're doing in this assignment is practicing your PEMDAS, order of operations. You simplify your parentheses first. -6 minus 6 is -12. Okay, now we got to do exponent, right? Because we're doing PEMDAS here. There are no exponents. Excellent, good. We can move on to multiplication. Let's do that. Okay, so now I'm going to do -1 times by -12 is +12. So then we have +12 times by A. We get 12A. Very nice. So what's our stretch factor? Well, it's 1. This is going to be very similar to the parent graph, right? Parent graph, Y equals X squared. It has an A of 1 as well. Here, divide both sides by 12, and 1 equals A. Okay, so there's nothing particularly special about how wide or how skinny this particular parabola is here. So now we just write the final equation. Be sure to, your graph, what does that mean? Move myself out of the way. Hits all points. Well, let's check it out. Fingers crossed. I feel like I might have done something wrong because it was too easy. I got Y equals, that A equals 1. So anyways, Y equals, you don't have to put the 1 there actually, even too, because it could be an invisible 1 in front here. We got 1 times the factor X, what was it, +5 times by X minus 6, fingers crossed, and boom, boom. There we go. No fireworks this time. I think that's good enough here. That was just, we'll take some good golf clap for ourselves here. All right, click submit. There we go. And yeah, that's it. All right, reflection, write down what did you most understand today? What questions do you still have? I'll try to take a look at this for the answer tomorrow. Okay, so tomorrow, Thursday is asynchronous set. You might be watching this on Thursday because I'm going to tell you to watch this video actually for your asynchronous problem set. Is going to be similar problems, hopefully, where you're going to have to solve for A and use that to help you find your final equation for your parabola. That's kind of what you're trying to create given the points in a vertex or a point in 2x intercepts. Okay, thank you guys for watching. Thank you again for your amazing work so far this year. I've really enjoyed Algebra 1 this year. Message me if you have any questions. Take care. Thanks. Bye.